This is Euclid Book 1, proposition number 31. And I'm going to start this out by saying that we're going to stop the calculus lessons just long enough to get you to Euclid Book 1, proposition number 47. And I have a reason for doing this. Just bear with me and keep studying these Euclid's elements, because when you reach 47, you're going to understand why I stopped this for calculus. Alright, now, let's go on with this proof here. First of all, Euclid says, I'm going to give you a line, it's going to be BC. That's a given. Then Euclid says, I'm going to give you point A. And then he says, I want you to draw a line EF, and EF has to not only go through point A, but it has to also be parallel to BC. How are we going to do this? Alright. First of all, Euclid says, I want you to pick a point anywhere on BC, and I want you to call it D. And once you do, I want you to draw a line between D and A. We have done this, okay? Now this EF line doesn't exist yet, alright? I know it does on this piece of paper, but when you start this proof out, it's not going to exist. All you're going to have is BC, and you're going to have a little point called A, and now you're going to have a line between D and A. And then he says, by using Euclid's Book 1, proposition number 23, you remember how I talked about Book 1, proposition number 23? He says, I want you to draw a line between he wants you to draw a line starting at point A, ending at point E, and when you do, this line, this angle right here, DAE, see that angle right there, DAE? Okay, it's going to be equal to ADC. Now, how are you going to do this? Well, you're going to draw a triangle. See this triangle right here? Now, let me show you how this actually works. Okay? Let's say we had a triangle like this. Now, we're going to go back to Euclid proposition number 23. You have a triangle like this. Now, if you were to fold out these lines here, if you were to draw this line out to here, and this line out to here, then you'd have one giant straight line with all three of the sides included. Alright? So, when you draw the line over here, you're going to copy this one super humongous line, you're going to copy it right over here. And if you were to draw an angle up, an arc up to here, with center point here and outermost edge here, strike an arc, outermost point here, center here, another arc, that arc's going to meet someplace. Where it meets, then you draw the lines. Then you're going to have a triangle which is equal in size to this. And that's exactly what we have done here. Okay? We drew this triangle. Obviously, this side is going to stay the same because this is one of the sides of the new triangle we're going to draw. This base here was drawn right here. So AH actually equals the length of DG. Okay? And then we'd have one more length from H to D, and it would be equal in size to the length of A to G. Okay? So therefore, this angle here will equal this angle here by proposition 127. Okay? Alright, so then Euclid says, I want you to extend the line of EA to go all the way through point F. Well, when you extend the line of EA all the way through point F, you're going to have one solid line. And because EAD is equal in size to ADG, then we can say that line EF is parallel to line BC. And that was what we were required to prove. Therefore, we have now proven Euclid Book 1, proposition number 31. You have yourself a good day, and I'll tell you more in a future video, so stay tuned.